Hey, what's going on, guys? Let's do this problem right here. The question is asking to find the volume of this expression, and here we have the expression right here. The first thing we have to do is we have to draw the graph, right? So let's draw the graph of this one. So the graph of this is going to look like this, right? So this is how it's look like, and then they are saying it's rotating around y-axis, so it's rotating around y-axis. So everything is going to be in terms of y. So the region they have provided, that's 0 to 1, x is 0, y is 1. So this is the region this is going to be the shaded region, right? So the only thing we have to figure out is we have to figure out the radius. The radius is going to be from here to here. If it's x region, it's going to be starting from here to here, right? If it's y region, it's going from here to here. And this distance is called ry, radius in terms of y, and this is also same as x. And we know this, since the equation of the line is this line is equal to y is equal to x power 2 by 3. Since from here to here this touches this line, so the x is going to be equal to what is it, x power 2 by 3. But we know that r of y is equal to x. R of y is equal to x. Therefore, that's going to be equal to x power 2 by 3. X power 2 by 3. But we have to write this in terms of y. How we can write it? So let's see what we can do. Here we have y is equal to x power 2 by 3. To convert this one into x, what we can do, we can simply power both sides by 3 by 2 to cancel this 3 by 2. So if you 3 by 2, this is going to be cancelled, and in this side we are going to have 3 by 2. So x is equal to x is equal to y power 3 by 2. So that's going to be the radius. X is equal to y power 3 by 2, and that's going to be the radius. This x and this expression x totally different, so we shouldn't confuse that. This represents the distance. The distance is calculated by subtracting this line by this line. This line is 0, x is equal to 0, and this line is this value. So all we have to do is, so this is going to be when we have it from the origin, like if it's from here, it's going to be just the value of this line, and from here same as that one, the value of the line. So here it's going to be x squared by 3. So that's going to be the radius. Since we have the radius, we can directly apply this one into the equation, and that's going to give us the volume. So let's write ry is equal to y cubed by 2, and the volume equation is going to be 5 times integral, and we have to know the limits of integration. That's basically this one, 0 to 1. So that's going to be the limits of integration, and that's going from 0 to 1. Then we have y power 3 by 2 dy, and yeah, now it's easy to integrate. Let's do the integration. 5 y cubed divided by 2. If we integrate this one, we have to add 1 to the power. That's going to be 2 by 2. So this is going to be 5 by 2, right? Y power 5 by 2 divided by 5 by 2. And that's going from 0 to 1. And if I flip this around, this is going to be... I made a mistake right here. Area of a circle is going to be 5r square. So we have to square this one first before we do the integration. If I square it, this 2 cancels. So everything is going to be different. Okay, so let's go and fix it. So this is going to be 5 going from 0 to 1. and if I square this one, this is going to be just y cube dy, and if I integrate this one, this is going to be y power 4 divided by 4, going from 0 to 1. Let's substitute the value. 1 power 4 over 4 minus 0 power 4 divided by 4. 0 power 4 is going to be just 0, and divided by 4 is going to be, the whole thing is going to be 0. So only thing we will be left with is 1 over 4. So 5 multiplied by 1 over 4 is basically 5 over 4, and that's going to be the volume. And that's how we do these kind of problems. I hope you guys like this video. See you next time.